Hello everyone and welcome to the channel. In this video, we are going to use Python to solve the facility location problem. Assume that your company is exploring a new market and they asked you to help them to identify where is the optimal location to open their facilities. They told you that their potential customers are located in 5 different regions and they have 4 potential locations where they can open their facilities. Assuming that the demand by these customers is known and also the transportation cost between the potential facility locations and the customers is also known. So they want you to help them to identify which facilities in which locations to open. Shall they open all the 4 potential facilities? Shall they open only 1 or 2 in order to minimize the operational cost and also to fulfill the demand by these customers? So let's see how to solve this in Python. So first, let's see what are the input variables given by the problem. So we have 4 potential locations and we have 5 customers. We have the demand for each of these customers. So customer 1, the demand is 3 tons and so on. And also we have the transportation cost between the facilities and the customers. So for example, the transportation cost from facility 1 to customer 1 is 300, and from facility 1 to customer 5 is 400, and so on. And also we have the opening cost, the fixed cost for opening each one of these facilities. So to open facility 1, the cost would be 250,000. To open facility 4, the cost would be 220,000, and so on. And also we have the capacities for each of these facilities. So if we are opening facility 1, the capacity would be 12 tons. If we are opening facility 2, the capacity would be 11 tons, and so on. What are the decision variables that we have to make to solve this problem is which facility to open. Shall we open all of them or only 2 of them, 3 of them? And also from which facilities we will fulfill the demand of these customers. So if we are opening facility 1 and 2, which one will be serving customer 1, which one will be serving customer 5, and so on. What are the constraints? The first constraint is that the quantity served from the facilities to a specific customer must equal exactly the demand by that customer. The second constraint is that the quantity served from a specific facility should be less or equal to the maximum capacity of that facility. The third constraint is that we only serve from a facility if it is open. If the optimized solution is saying that this facility must not be open, we're not serving any customers from that facility. What is the objective function? The objective function is to minimize the overall cost, which is equal to the fixed cost associated with opening the facilities. So if the optimized solution is saying we open facility 2 and 3, what is the fixed cost of opening these 2 facilities, plus the cost of transportation between the opened facilities and the customers. Now let's see how to solve this problem in Python. First, we need to import some libraries. So from py opt import model. So this is going to be our optimization model. And then we need also quick sum. This is a summation function. And also we need multi-dict, which is also the function to handle multiple variables in a dictionary. Next, we need to define our main function. So we define a function, facility location problem, and then this function takes 6 arguments. It takes I, number of customers, J, number of potential facilities, D is the demand for each customer, M is the maximum capacity for each facility, F is the fixed cost associated with opening each one of these facilities, and finally the cost, the C is the transportation cost between the customers and the facilities. And then we need to pass our model equal model. And then we need also, then also we need to define X and Y, which is going to be for now empty dictionaries, and it will contain our decision variables, which is the number of facilities and the quantity delivered from each facility to each customer. Now let's add the decision variables to our model. We have to create a for loop. for j in j, yj equal model dot add variable v type equal d. This is our first decision variable, which is the facility, whether it's open or closed. So if the decision is 0, then it's closed. If 1, that means we open this facility. And then similarly, another for loop will be for the edges, then I, which is going to contain the quantities from each facility if it is open to each customer, to serve each customer. So for I and I, X, I and K, as we said, this is going to be an edge between each customer and each facility. If it is open, what will be the quantity delivered from this facility? So X, I, and J equal model dot add variable v type equal c, which is continuous, because this is going to be quantities. It's not a binary. Now let's add our constraints. The first one is that the quantities going to a specific customer must equal to the demand by that customer. So the summation of all edges, all quantities for a specific customer coming from different facilities must equal to the demand of that customer. The second constraint is that the quantities served from a specific facility must not exceed the maximum capacity of that facility, so that the summation of all edges, all quantities going to the customers from a specific facility must not exceed the summation or the maximum capacity of that facility times the decision variable if the facility is open or not. Last constraint is that we only serve a customer from a specific facility if that facility is open. So for each individual edge going to any of the customers should be less than or equal to the demand of that customer times the decision variable if the facility is open or not. So if the facility is not open, we are not serving any customers from that facility. Now let's define our objective function. So our objective function is going to be the overall goal is to minimize the cost. But what we are minimizing the summation, the summation of the fixed costs associated with each facility and times whether the facility is open or not, times y of j for each j in j for each facility in our problem. Plus, also, what is the other cost that we have is the transportation cost. So the summation of the transportation cost, c for each edge we have, y and j, times the edges. So there is a cost to go from customer A to customer J that we need to multiply for all our edges, y and I for j in j, for the whole network. So this is our overall objective function, is to minimize the overall cost, which is the summation of fixed cost plus the summation of the transportation cost. And then model.data equal x and y. So we'll say data from the model in x and y, and then return the model. Okay, so let's run this. Let's define our input variables, which is given by the problem. I'll just copy and paste them to not waste a lot of time. So we have the demand by each customer, which is I. So customer number 1, the demand is 3 tons. Customer number 2, the demand is 5 tons. And customer number 3, the demand is 1 tons. And then customer number 4, the demand is 8 tons. And finally, customer number 5, the demand is 4 tons. Remember the multi-det function we imported here to handle these multiple variables in this dictionary. Similarly, for each facility, we have a maximum capacity and we have a fixed cost. So for facility number 1, the maximum capacity is 12 tons, and then the fixed cost to open this facility is 250,000. Similarly, facility number 1, the capacity is 11 tons, and the fixed cost to open this facility is 200,000, and then the same for facility number 4 and number 3. And finally, we have the fixed cost, the transportation cost here, which is between the facilities and the customers. So from facility 1 and customer 1, so this is the cost, 300 USD, and so on and so on. So we have 5 customers, we have 4 facilities, and this is 20 elements for the cost associated with each edge between each facility and each customer. Here, I think we used C capital here. Yeah, so we are using C capital. We will see this later if we get any errors. So this is our input variables. So now we are ready to go and solve the problem. Now we are ready to solve the problem. So model equal, so we will call the function that we have defined, and we will pass all the input variables A, J, D, M, F, and C. Then model dot optimize, we are solving the problem, and then X and Y equal model dot data. Now we want to access the values in the solution. So first thing, we need to know the active edges. So the edges will be equal to loop through all the edges in the solution in X and return for me only the edges that have any positive values associated with them. So it will be more than or equal any small positive number. Next, we need also to know the facilities that have been open. So loop through the decision variables in Y and return for me only the positive ones. That means only the facilities that have been, or the solution is saying that these facilities should be open. And lastly, we want to know the quantities that have been served from each facility to each customer. So loop through the solution, and for each edge, return for me the associated quantity sent from this specific J to this specific I, from this specific facility to this specific customer. Finally, let's print the solution. So print, let's say, optimal value or optimal cost would be model dot get objective value, which is from the objective function, which is to minimize the cost, and also print the facilities to open equal, and also facilities. Okay, let's print this. So the optimized solution is saying that the optimal cost would be 427,600 if you are opening only facilities 2 and 4. So out of 4 potential locations, the optimized solution is recommending to open only facility 2 and facility 4 in order to minimize the cost. And if we want to know what are the quantities served to each customer from these facilities, we can also add this. I'll just copy it and paste it, loop through the solution, and to give us the quantities. So from facility 2, we'll be serving customer 4 to meet the demand of this customer, which is 8 tons. And then facility 4 will be serving the rest of the customers, which are customer 1, 2, 3, and 5. So we're opening 2 facilities. One is serving only 1 customer, and one is serving the rest of the customers. This is our optimized solution.